Hey guys, welcome back to the Unit 7 test review video. There was one thing that I forgot to mention on the first page. If we were to have done this by hand, would we have gotten the same answers? The answer for that is no. When you do something by hand, it is only an approximation to where when you do it on the calculator, it gives you more exact values. So, remember, doing it by hand is only an approximation. We're going to go on to our second page. So the following set of data is a random sample of bowlers' scores. Use the following data set to compute the MAD, which is the mean absolute deviation. Remember that if it asks you for the MAD, that is the mean absolute deviation. So the first thing that you need to do is import all of this into your data set. 110, 220, 105, 150, 210, 200, 190, and 230. When we do this, we'll calculate the mean. Our mean here is 176.88. And to calculate the MAD, remember that we line up all of our values. We're going to take those values and subtract it from the mean. Or subtract the mean from those values. So we have 110, 220, 105, 150. We'll have to do this again. 210, 200, 190, and 230. A way to do this quickly is to go into table and to do x minus that mean. Instead of auto, we'll go to ask so that we can get these numbers quickly. 110 gives me negative 66.88, but remember we only take positives because it's the absolute value. 220 gives me 43.12. 105 gives me negative 71.88, but remember we're only doing the positives, the absolute value. 150 gives me 26.88. 210 gives me 33.12. 200 gives me 23.12. 190 is 13.12. And 230 is 53.12. We'll do all of these, put them back into our data set, the numbers that we just found. And we will find the average of these. So the average here is 41.41. When we find the X bar for this, that's going to give you your MAD, which again is 41.41. Next, we're going to look at another data set and find the boundaries. So we'll go back to data, clear it out, and input these numbers. We'll do second data, one variable stats, and calculate all of those things. So remember to find our upper and lower boundaries, we have formulas to use. To find the upper fence, that's going to be Q3 plus 1.5 times my IQR. And my lower fence is going to be Q1 minus 1.5 times my IQR. Before I can do that, I need to find my Q3, my Q1, and my IQR. Q3 is going to be 13. Q1 is 7. And to find the IQR, we take 13, we subtract 7, and that gives me 6. So now let's find our boundaries. So the first thing that I want to do is find the upper boundary or the upper fence. We'll take Q3, which is 13. We'll add 1.5 times 6. We can put that directly in the calculator, and that gives me 22. To find my lower fence, I'll take my Q1 value, which is 7. I'll subtract 1.5 times my IQR of 6, and that gives me -2. Do I have any outliers? Well, let's see if I have any numbers above 22. 4, 13, 12, 8, 5, 26 is above. 7, 13, 9, 23 is above, and 7. So we have 2 outliers above our upper fence, and we don't have any below -2 because none of our numbers are negative. All right. Next, given these 2 box plots representing weights of baby chickens for different types of feed, what are the 2 comparative conclusions that can be drawn? So, our first conclusion that we can state is that feed 2 has a higher median. So, this one right here, its median, which is the middle, is higher, which means there are larger chickens. And then for feed 1, if we look at their IQRs, so this one is about 260 and this one is about 375. If we do those numbers, 260 minus, or 375 minus 260, that's going to give me 115. This one's about 255 and 175. If we take 255 and subtract 175, that's going to give me 80. So feed 1's IQR is smaller. Which means that feed 1 is more consistent. So, since we just said that, part C wants to know who's more consistent. We can say feed 1 because the spread is smaller. So we have a smaller IQR, which is a spread. Do we see any kind of skew for feed 2? For feed 2, we notice that the left side from our median all the way to the end is larger than the right, more significantly larger. So we will say that feed 2 is skewed left because it has a longer left-hand side. And last but not least, the following information, we want to see how we can describe this histogram. So, if we draw a line over it to kind of see the shape, we can see that it only has one peak. Since it only has one peak, we're going to say that it's unimodal. That means one peak. And since the left side has the tail, that means that it's going to be skewed left. Now to page 3, number 9. Using the information provided below, create a two-way frequency table. 41 people went to the Raider basketball game. So we know that there are 41 people in total. Of those people, 8 had pizza with water. So pizza with water, there were 8. 12 people had soda with a hot dog. 4 people had nothing to drink. Oh, nothing to drink with a hot dog. Excuse me. 19 people total had soda. 16 people total ate pizza. 7 people had soda and pizza. 1 person had water with no food. And 15 people had water. So now we need to fill in the rest. So to find how many people had water and a hot dog, we can take Sorry about that, my calculator's not working any longer. We can take 15, subtract 8, and subtract 1. And that's going to give us 6. To find how many total people had hot dogs, we can take 12 plus 6 plus 4, which is going to give me 22. To find the total of people that had no food, we'll take 41 minus 16 minus 22. That gives me 3. And to find out how many people had no drink, we'll take 41 minus 19 and minus 15. That gives me 7. Now we can see how many people had soda with no food. We'll take 19 minus 12 minus 7, and that gives me 0. We can see how many people total had no food. We have 3 in total, only 1 person in that column. 3 minus 1 minus 0 gives me 2. And then for pizza, we can take 7 minus 4 minus 2, and that gives me 1. There you go. So the totals, what type of frequency is this? We know that all totals are always marginal frequencies. How many people had water and a hot dog? Water and a hot dog is 6 people. Is that joint or marginal? This is going to be joint because it's found under hot dog and water. 2 things come together to give me that number. That's why it's joint. A marginal, remember, is a total for a single column or row, only calculating one thing. For people who bought a hot dog, what is the conditional relative frequency that they did not buy a drink at the game? So hot dog with no drink is going to be 4 out of 22. We take the total of people that had no drinks and hot dogs out of the total people that bought a hot dog. And that's going to give me 0.18 or 18%. What's the conditional relative frequency of people who had something to eat given that they had a water? So the total number of people that had a water were 15. And people that had something to drink, that's either a pizza or a hot dog, and that is 14 people. So 14 out of 15 had something to eat with a water, and that's 0.93 or 93%.